have seen the reason why we need to transmit at a very high voltage. So now we are going to look at the transformer, which is one of the major components in the transmission system. So, you know, the first transformer that we meet in the transmission system is the step-up transformer or the transmission transformer. Okay, so like the name implies, its major function is to transform the voltage from one level to another. That is the major function of the transformer. Then in this case, we are looking at the transmission transformer or a step-up transformer, which means that its function is to take the voltage from that 11 kV generated to 330 kV to be transmitted. So that component, that electrical equipment transformer, the transformer has some components. The major active part of the transformer is the windings. So the windings is where the transformation is actually done. And these windings, as you can see, they are wound on an iron core. Okay, so this is the active part of the transformer. But for the transformer to function properly, there are other parts also in the transformer. We have the connection bushings, okay? Since it's a step-up transformer, this is the high voltage bushings, and these are the low voltage bushing. On top of the tank is what is covering the main active part of the transformer or the transformer windings, okay? So when you also see, you see that we have a radiator-like structure on the tank or around the tank. These are meant for cooling the transformer. Since in the course of operations, because of the effect of I square arrow, power losses are bound to be around the windings of the transformer. And these power losses, definitely, they will come in the form of heat. So those heats, we need to take them out of the transformer. And that is where the transformer oil comes in. So the transformer oil, apart from doing the work of cooling the windings, it also helps in insulating the active parts from the inactive part of the transformer. Okay, so let us see in a little detail each of these component parts of the transformer. So, like we said, the first part is the winding, and this is the winding. So on these windings, we have the primary and the secondary sections of the winding. So the input voltage, in our case, that the 11 kV comes into the primary windings, and this is the low voltage bushing. Okay, so the 11 kV will come into this low voltage bushing. Then the secondary winding, after the primary winding has been magnetized, since it is an alternating voltage signal that is sent into the primary winding, EMF or voltage will be induced in the secondary windings. So the 330 kV winding, 330 kV voltage, 330 kV signal that is induced in the secondary winding is now connected to this high voltage or output bushings. Okay, so all the output terminals from the secondary windings, they are tied to these high voltage bushings. So the major active component, as we said, is the windings, and that is where the transformation is done. So when you also look, you see that we have the transformer core, okay, and then we have a former on which the winding is wound. So this core, its major function is to concentrate the magnetic field that the primary windings generate onto the secondary winding, so that we can have the most or the maximum induction as much as possible into the secondary windings of our transformer. So the other component that we want to look at now is the tank, and this is the tank. The transformer tank is what is housing the main winding. Okay, so the winding and the core, they are placed inside the transformer tank, as you can see. And also it's the part that also houses the insulating oil, or the oil that helps to cool the transformer winding. So the tank also, as you can see, also carries all other components, both protective and those components that are needed for the transformer to function properly, like the bushings, they are on the tank. The conservator, they are on the tank also. Even the radiators, the cooling fins, and what have you, they are all attached to the transformer tank. So we also have another very important section of the transformer, which is the cooling system. Okay, so we know that once the transformer is loaded, heat energy will be released. Okay, that is because of the I square arrow losses. So that power that is lost when the transformer is working, we need to remove them from the transformer, or else it may cause the transformer to degenerate to a situation where it will just fail. Okay, the insulation will complete the winding, the insulation of the winding will completely fail. So since we need to remove this heat, we need to have a system that will help us to do exactly that, and that is what the cooling system does. So the cooling system is a combination of the oil within the tank and the cooling fins, as we'll see later. So the heat generated around the windings, okay, being that the transformer oil is in contact with the winding, by conduction, the oil molecules conduct that heat away from the windings. So those molecules that have gained enough energy, okay, from the transformer winding, they will tend to move away, natural convection, move away from where they collected the heat or where the heat is being generated. So as they are moving away, cooler oil molecules will take the place of those hot oil molecules. So those hotter oil molecules, they will move, okay, to the tank body, and by conduction, they will give off this heat to the tank body, and then the tank will give off the heat to the surrounding or the atmosphere. That is how the radiator also works, because here we have cooling fins. These cooling fins, there are openings within it, okay? So the function is actually to spread thin the oil molecule so that we'll have as much surface area contact as much as possible, okay, with the fins that will conduct the heat away from the oil molecule. So as the fins conduct the heat away from the oil molecules, air molecules that are trapped around the fin outside the transformer, okay, those air molecules will now conduct the heat away from the metal, the material, okay, which will now be the molecules of the fin material, which will now be hot in the external. The air in contact with it, the air molecule in contact with it will conduct that heat away from the fins. So you see that with this kind of arrangement, the heat is taken from the windings through conduction by the oil molecules, and that oil molecule moves away to either the tank body or to the cooling fins, okay, and gives off that heat to the fin material, the metal used to make the film. Then that heat conducted from the oil molecule into the film is given off to the surrounding air molecule, and then the air molecule will help to take the heat away. So that is how the cooling is done in the transformer. So we also have other protective systems that protects the transformer against excessive temperature. We know the effect of excessive temperature as we stated earlier. Okay, so because of that I square arrow effect, as you are loading the transformer, the heat will degenerate to a stage that it can cause the breakdown of the winding insulations. And once that happens, it can cause turn-to-turn short or short to ground, as the case may be. So all of those, they are undesirable circumstances or situations that we do not want, okay, in our transformer. Then we also have protection system that protects the transformer against overload that will eventually cause overheating, and also that protects the transformer against shortage of cooling oil, okay, or shortage of transformer oil. Short to ground also, there are systems that protect the transformer against that kind of fault problem, over voltage, under voltage, and also internal faults within the windings. Okay, we have protection systems that protects the transformer against all of such. So we'll see some of them later in the course of this section of our training. So here are some of the components of the transformer that helps us to protect the transformer. So we know we have oil within the transformer, and we know that because of the thermal expansivity of oil, as it is being heated, it has that tendency of actually expanding. So once your transformer tank is filled with oil, as it is working, you know heat is generated. Apart from the heat that is generated, changes in the weather condition of the day can also affect the temperature of the oil. So once it is heated, naturally the oil will expand. So if the oil that is expanding does not have anywhere to expand to, that can cause overpressurization of the tank, okay, and may either cause explosion or may cause the compromise of the gaskets that are between the cover and the tank, and that can cause serious leakage. So that is why this conservator tank is here. So the conservator tank is meant to accommodate the excess oil as it is expanding. So as it's expanding, the oil will now expand and move through this pipe to the conservator tank. Okay, so when the oil is cooling back, the oil in the conservator tank, all of them will now condense or shrink back into the main oil tank. So those problems that are associated with the expanding oil not having where to expand to will now be eliminated by the conservator tank. So that is the conservator tank that you are seeing there. Then another simple protective component that you will see in some transformers is the explosion vent. Okay, the explosion vent. So that explosion vent is like a relief valve, so to say, a pressure relief valve. So we know that if there are internal faults, there are some faults within the windings that can cause the generation of hydrogen gases. Okay, so as the oil molecule is disintegrated, hydrogen is formed, and that hydrogen, as it's forming, it moves up naturally okay, and to pressurize the tank. So if the rate at which that hydrogen molecule is formed, okay, is very high than is higher than the rate at which maybe it is getting out somehow, either through the breather, okay, you will see that the pressure in the tank will build up to a stage that it can cause explosion of the tank. So the explosion vent helps us to avoid such a situation in that the disc, the pressure disc around that vent will break, and then it will break and release that pressure, excess pressure from the transformer. So the issue of explosion will not be there. Okay. So the bushings, like we said earlier, is meant to insulate the active part from the transformer body. And like we said before, when there are some faults within the windings of the transformer, you see that that may cause arcing within the windings. And we know that arcing in itself is a very high thermal event, and that can cause the dissociation of the oil molecule, breakdown of the oil molecule, and thus generating hydrogen. That hydrogen, if it is not removed from the tank, will definitely overpressurize the tank, okay? And if the tank is overpressurized, it will get to a level that it can either cause the gaskets between the cover and the tank to start leaking, or it can cause explosion. Okay, depends on the rate at which that hydrogen gas is generated within the transformer. So the explosion vent actually assists us in preventing such an occurrence or situation.